Recording in progress.
So I'll need to first confirm that my building analysis is still active and analysis. It is still active. Okay, so now when you're doing foundation design, you're going to go to story 0 in the plan. You go to the plan tab. Yeah, if you check and it's not active, you rerun the building analysis. But then that would mean that you lose the design aspect that you had done for the beams and columns, because it will be just updating. You have to redesign them. What causes it to stop being active in case you have deleted anything? Or in case you have to double click and change the properties element, just like if I double click like this and I attempt to adjust any property on this beam and I click update, the building analysis will be invalidated because this is not the appropriate way of correcting a failed member. You get it? So let's do foundation design. You're saying? Yes. If the work we did last week, it's not there. What do you mean? It's like you didn't save after design. If you didn't save after design, it is okay. If you check your building analysis and it's still active, is it active? If it is still active and you didn't save, it is okay. Your results are still there. What happens is that in case the building analysis is not active, you need to rerun the building analysis before you can perform another design. You get it? Yeah. So let's switch to plan and open story 0. Double click and open story 0. So at story 0, we click on one column. We select the column. Then you right click on it and choose insert pad footing. Insert pad footing. Is this one? Freeze here. Okay, you'll get this dialog box. And from here, you need to look at this value in the design. First of all, once you click on insert pad footing, Plotter will bring the results when it has designed a suitable like depth and size of the footing, and it will give you a design is successful. But then it is successful with what properties? Our allowable bearing capacity of the soil was 200, but Porter has a tendency of designing the footings with a default allowable bearing capacity of 250. This. So when you look at this, these limits, it's saying 250 is less than 249.11. So we need to go into the materials. Under materials, you set the ultimate stress of soil using a member-specific value. You click on this box, you tick it, and adjust this to 200. Adjusting it to 200. Now we look into rebars. Once you click on rebars, you notice that now the design has failed. The design has failed because the 200 soil bearing capacity has been, like, it's less than what the average pressures that have been computed by the program. When you check on the vertices of the footing, the average pressures range from 240 onwards. Yet our SBC, also bearing capacity, is 200. So once this shows that it has been exceeded, we need to look into the geometry and adjust the contact area of the footing with the soil. So under geometry, let's adjust this depth, adjust the depth of the footing to about, let's say, 500. If we take it at 500, and then look at LX and LY. So this gives us a rectangular footing, but in case you want to design with a square footing, you can force the design by marking this box. So if I mark this box to have a square footing, when I adjust this, it will restrict these dimensions to a square footing. Unless you want it to be rectangular, then you can ignore this. Okay, let's just keep it default. And then we keep on adjusting the LX and LY interchangeably. Adjust LX by clicking on these arrows up, until it shows you that the design is successful. Right now here, what is making it to fail is shear check at face of column in the X direction. The capacity to demand ratio has been exceeded. The same applies to the Y direction. So we need to look into now the reinforcement. Okay, let's check under rebars. I'll click on rebars. Let it be rectangular. Now, if you look at rebars, the 3D, we can click on the 3D and we get a preview of our footing. You right click and hold, rotate this footing. Now, when I check at this, I'm having only the bottom mat. I don't have top still. Top rebar in X direction and Y direction has been marked, but we excluded it in our design preferences, if you remember. We turned off the top mat. So we have remained with the rebar in X and Y, but then it has given us a diameter of 20 at a spacing of 250. So in case you want to increase the number of bars, then you deal with the spacing. So I'll change the spacing to 200. I'll change it to 200. And once I change it to 200, I keep monitoring the design results down here. So we still have the shear check at the column face failing in both directions. I'll change it, this one 200 as well. I'll change to 175. I'll move in increments of 25 or 50. Okay, so I'll put 175 and check. It's still giving no response. So then that means that adjustment in the reinforcements is not going to cause any impact on that design. So you resort back to geometry and keep on adjusting the contact area. So I'll push LX, increase it. Once I increase LX, now the capacity to demand ratio in the X direction has been satisfied. Then I look at the Y direction. I'll increase the Y direction as well, just one step. Then I check here. It is still demanding. Then I'll increase it again. Still demanding. I'll increase it. I'll increase it again. And then until now, the more I increase in the Y direction, I have a difference of 0.4, which is left. So I need to increase it again. And then once I have 2.2 by 2.5 footing, the design will be successful. Now, it can be successful, but when you have over-designed again. So after it has given you a successful design, you need to confirm now in this other direction as well. You say, what if I reduce? I got 2.1. It will still be stable. Then you reduce again to 2.4. You check the design is still successful. So you check again by reducing to 2.3. It has failed. Then that means that this I can restrict it to 2.4. And then I iterate the X direction as well. If I reduce it, it is now still successful. I can keep it at this size. Okay, so now I've got a footing which is having a depth of 500 and a footing size of 2 meters by 2.4 meters and is having a single mat. Now, you see this size of footing, 2 meters by 2.4 looks to be a small size, but when you go to site, like physically, this is going to be a big area. So you have a big area with reinforcements which are T20s, okay? So you now resort to reducing the reinforcements to a lower diameter, okay? And check, it's better you have a lower diameter of reinforcements like in a big contact area of a footing. You get it? Because it is better to have concrete, which is much, than having steel, which is too much, and it's having bigger diameter. Okay, so let's reduce this to 16. If I reduce this to 16, I monitor the design. You see, the design here, it is still successful. So I also monitor the spacing. If I take it back to 200, you see, now 16 is also passing. I will try to increase the spacing of this rebar, just reduce the number of bars, like the quantity that is required, and check. If I also increase this to 250 and check, I will check. The design is still successful. Then I can confirm that my footing is going to have 11 T16s in one direction and 9 T16s in another direction, with a size. If I go back to geometry, with a size of 2 meters by 2.4. Okay. So then I can click on generate report for this footing. I'll click on generate report. Now, once you have done all these iterations, don't click on design. The moment you click on design, it will take it back to the default design status of the program, rather than the ones that you have customized. You get it? So once you have made these iterations and find that your design is successful, you just go and click on generate report. There is no minimum diameter. Okay, the minimum is there because now you cannot put R8 or T8 like as longitudinal reinforcement in the footing. That is shear steel. So when you're designing, take it that the least diameter of reinforcements or longitudinal steel that you can have is a 12 millimeter. Okay, so there is no limit for maximum, but what will constrain your maximum rebar diameter, it will be the cost constraint. No, maximum bar diameter. Then the maximum spacing is also attached to the cost constraint. If I have a bigger spacing, then that means I'm going to have less reinforcements. Therefore, less cost. Okay? Yeah, just like that. So this will be, yes. Now, that contact area, you will not have control over it. It is being dictated by your allowable bearing capacity. You get it? If you put the allowable bearing capacity and the software finds out that from the computations it has done, the average pressures on the different vertices of the footing has been like it's exceeding the allowable soil bearing capacity, then definitely it will demand you to increase the contact area. You increase it until you find that the design is successful to your satisfaction. You get it? It can be successful, but when it is an over design, like I just illustrated, we got it when it's successful with a bigger size, until we came back to a lower size with the with the less reinforcements. You get it? So when you are making these adjustments, you touch on the reinforcements, you touch on the contact area at the same time. Yeah. Mm. Mm. We have different like design values. Now, my LX is different from your LX and has. Are you sure that you have chosen the same color that you have designed? You have chosen the same color. The same that, let me check. Now, actually, let me first close this report. From here, you can save it to Word. So let me close this report. I'll click OK. I'll first click OK. Now, you check the axial load that you have on your column. If it's the same as has, then there must be a problem. If you have the same axial loading, then also the footing designs that you're going to have, they must be the same. But then in case the axial load is different, you cannot have the same footing. You get it? It's just like when we are doing column design. I can model the same column the way you have modeled it with even the same loading. But then the distribution of those loads on that column and the nearby elements can vary, which leads to a change in the axial load for those particular columns. Therefore, you're going to get different results. But again, the results are going to vary. But again, the variation shouldn't be too much. You get it? Yeah. So that is one footing. Now, if you look at this footing, the size it has given you, this is an axial load of, it has a maximum GK of 404. Now, when I look at this one, it has a maximum GK, or the permanent load, of 289.5. Now, there are chances that in case I make a design for this footing is this footing is going to overlap onto this footing. Let's select this one. I'll choose this footing. Then I'll still insert pad footing. It will bring it when it has designed it with a less contact area. Okay, but then the depth is 700. So when you look at this footing size, it is big. But when you go into the properties of that footing size and adjust the depth of the footing and increase it slightly a bit, you're going to get a less contact area. Because once you have a bigger depth of the footing, therefore the effect of punching shear on that footing is going to be minimized. You get it? So likewise, that is what is happening here. Okay, so if I keep this to be at, let's say, 600, it will make it failing. I'll adjust the materials and use a member specific value of 200 as my SBC. Then I'll look at the design status. You see, the SBC has been exceeded. So I'll go into geometry. I'll go into geometry, then play around with the LX and LY. I'll increase it gradually, both at the same time. I click on LX and also LY. Then until it gives me a successful design. Now this has been successful, but it is 2 meters and 1.9 meters. Okay. I'll check under rebars. I'll put this rebar to 16 and also this to 16. I monitor the design status, it's still okay. Then I'll come back to geometry. I'll come back to geometry and I critique this size. So it is passing with 1.9 by 2 meters, but there's still possibility that it could pass at a lesser size. I reduce this and it's still successful. Then I'll reduce it again. Then it fails. That means that the optimum size is going to be 1.9 ly. Then you look into lx. If I reduce this, it will fail. Then that means that for this design to pass, it must be a square footing of 1.9 by 1.9. Yes. 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 1.9 is too close, but the ultimate goal is having a pass. So you're taking it to 2, but 1.9 is passing. It will just be an over design. You get it? Yeah. So if you take it to 2, it is okay. But you have over designed, yet at a lower size, it could pass. Okay. Those values, even if they are too close, you see, if the soil bearing capacity, even if these values are too close, but when the SBC is less than, is more than what has been computed, it will still be okay. Okay. So I'll click OK. And I'll have that footing with that size. Now, assuming that the two footings, yes. Now, you see, when you look at this kind of, okay, these two footings, there is no possibility for them to be cast without having an excavation, like combining the two. Because now there is less space which is left here. If I can try to measure, this is like even 100 mm. Okay. Remember, this is the exact footing that will be cast, but there might be need for formwork on either side of the footing. Under no circumstance should these come into contact with each other. But even if they come into contact with each other, it's okay. You get it? So now when you resort to designing them as a combined footing, you're going to get, let me try to, you're going to get a footing of a bigger size. So if they are just close to each other, it is better you leave them like that, but then at implementation, you cast them together. Then if you attempt to design them as combined footings, it's going to give you a very big area. You get it? So now, like for example, let's design these two as combined footings because they are too close. Okay, these two here. Okay. So we select one column. And also hold control, we select this other column. So for combined footings, they must be selected at the same time. Hold control and select them together. Then you can right click and choose insert combined pad footing. Now, when you look at, just imagine for these two, the depth that it has given us is over 1.2 meters. Okay? That is quite a bigger depth. For an axle load, which is 289 and 322. Yet, for this other column, the axle load was in 404. But we managed to have a footing of 500 depth. Okay? So that means that if you are designing combined footings, you'll be expecting a bigger contact area. Okay? So let's have this depth adjusted to, let's have it adjusted to, okay, 600. I'll put it to 600 simply because there's one footing which we have designed and it is 600. Let's first test 600 and see what size it is giving us. Okay, so if we find that the size it is giving us, it is making like us also adding this onto the combined footing, then we can resort to increasing the footing depth. Okay, so I'll push it to 600, then monitor the design status. I'll first of all change the ultimate soil stress. I'll go to materials, then look into the soil properties and use a member specific value. You take it and let's have it as 200. Okay. We have it as 200 and we check rebar. So when you have combined footings, you need to put top steel. I'll tick this box to have a top mat and also tick this to have a top mat. Then get this diameter, lower it to 16. Get this, lower it to 16. Then I go to top rebar. Top steel, it is better you can have uniform reinforcement, but also there could be a scenario where you have the top mat when it is having less reinforcements compared to the bottom mat. Okay, so this top mat is added there to provide rigidity for the two supports. So we can have 16 and also 16. Then we look at the design status and get back to geometry. Now we iterate the soil stress. We adjust this contact area. Now, when I look at the orientation of my columns, I would expect for me to ensure that I don't have overlapping footings for these other two columns. Then I would expect to have my size of the footing, which is rectangular, in this format. Okay, so I would expect LX to be larger than LY. Then I'll come back here and adjust LX. I'll increase it gradually until it gives me that the ultimate soil stress is more than what has been computed. Okay, so it is taking me to a 3.3 in the X direction. Now in the Y direction, I'll look at shear face at column shear at column face in X direction. Also in the Y direction, the capacity to demand ratio has been exceeded. Then we also have shear at a distance D from column in the Y direction. It's also demanding. Now I need to switch on the 3D view when I'm making these iterations to see exactly what is happening. Okay, because this program is very funny. It can demand like reduction in the size until you are even close to the support, which practically is not, it's not right. Okay, so let's adjust now in the Y direction. I'll increase this. I'll increase it. I'll increase it as I monitor. Down here, I'll increase it. I'll increase it until it gives me that design is successful. So I'll increase it to, okay, I'll increase it more. I'll also increase this side in X. I'll push X. I'll still push X. Then I'll push Y. So it is giving me a successful design. Then, but now, if I try to click OK, I'll click OK here and I say, you see, it is almost into these two columns. I'll come back to its properties, right click on it, then access its properties, and change reduce LY. It can't be reduced. So I'll push it back. I'll instead resort to increasing this to about, let's say, 750. If I push it to 750, then I lower LY. I lower LY again. I lower it. 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 You see, at 2.9, it's failing. So at LY, I can achieve the design results when it is 3 meters. Then how about LX if I reduce it? I'll reduce LX. I'll reduce it. 3 by 3, 2.9, 2.8, 2.7, 2.6, 2.5. Okay. 2.2. Now at 2.1 in the X direction is failing, so it is passing at 2.2. I'll still test again in LY. If I reduce it, what happens? So it's still failing. That means that the optimum size of this footing is going to be 2.2 in the X direction and 3 meters in the Y direction, but with a depth of 750. Okay, so I'll click OK. And I'll have it with that size. Okay. So now there's possibility that you can design all these footings at once, but it's not a feasible option to take when you are designing a structure. So you can select all these columns as you hold Control and you right click and insert pad footing. So it will design all those footings at once. But then that means you'll have a lot of time that you will take like to correct all these footings. Okay. So if I click OK, you will have them designed, but with varying sizes. So now, what is the right thing to do when you are designing footings? Okay. So the right thing to do is look out for these axle loads. The maximum axle load among all these ones is going to be, you can look at them, maybe if it is 734, you're going to group these columns, okay? You're going to group these columns. Actually, let's look at that when we are exporting these details to AutoCAD, because that's the appropriate environment where I can discuss grouping, okay? Yes, you had a question? Yes. The difference is what? Is weak, is big. No. Now you need to adjust them like gradually. You increase X and then also increase Y up to a point whereby when you make a change in one direction, it can give you a fail, but when you apply that change in another direction, one step, it can pass. So that difference shouldn't be too much. If the difference is too much, you need to make those iterations again. You get it? Just like you see, if I right click on this footing, if I reduce this size to 2.9, it will fail, okay? Then I'll take it back one step to 3. And also if I reduce this to 2.1, it will fail. I'll take it back to 2.2. Note that if you reduce it to 2.1, it will still pass. Reduce it to 2, it will still pass. So you need to make sure that those steps, okay, that the margin between failure and a pass is a difference of one step. You get it? Yeah. So if in case you want to make a report for all these footings at once, in the drawings and reports, sorry, in the design, when you click on pad footings, it will open this environment where you can get a detailed report for all the footings at once. Okay, so but it is better you export these reports element per element. But in case you need this report to be captured in the reports manager, then you need to use this option of a detailed report. So once I click on detailed report, the detailed design report, it will take its time to generate the report for all the footings in this interface. Okay, so now this is a report for all the, how many footings? About 10 footings that I have designed. So you can take it to Office and then to Microsoft Word and save it. So if I click OK, so how I got the report, I went to design, then pad footings. Remember, you have made your iterations. In this environment, you are supposed to just generate the detailed report. Once you click on design all or redesign all, it will take out all the design preferences that you have done and then take them back to the initial status of rotor design. And you lose all the inputs that you have adjusted. So in this environment, just go to detailed report. Just click on detailed report. It will take its time to generate the report. Yes. Yes. Now, when you're making a report for submission, that report, you shouldn't report on every structural element. No. You get it? So the report that is required is going to be a report which you have just generated by, for example, if I'm making these iterations, if I'm designing this pad footing, okay, properties, the report that you should attach in your design report should be element specific report. For the footings, I just identify any two unique footings, like for example, this combined footing and one other footing which maybe has a maximum axle load. Launch the properties of these combined footings that I have launched it, then generate that report from here. Okay, save that report. Okay, you see it's about like 4 pages. Save it to Word. Then go to another footing which you think is maybe different from the others. Like for example, this one, go to its properties, generate its report. Save it to Word. Then after you have saved them, you merge the two Word documents. You get it? You can use because it is already Microsoft Word. For example, let me just generate this one. I'll save it to Word. Then I'll save it to, I'll put it to this folder. Pad footing report, maybe this is pad footing F2. Okay, that is one report. I'll close it, close this. Then get to this other one, properties, generate its report, save it to Word. Maybe it's going to be F2. If I save it to the desktop in this folder, this could be F1. Save it. Okay, so now I have two reports of foundations. When you go to that folder, in the reports that you have saved, so these are the two reports, F1 and F2. I'll open F1. This header will be editable. So you can double click on the header. You can even delete this table and put your customized header of your company standard. You can delete it. So then I'll open another report that I have saved, which is F2. Then in this report, I'll delete this header or this table, and I'll copy every detail attached to this footing, Control A, then Control C to copy and paste in this document. I can go to the next page. You paste it here. So you need to edit it. So this is one document which comprises a report of footing F1 and F2. Okay, so the same thing you do to columns, generate two reports like for two columns, save them to what? Merge the documents. Then after you've merged them, get those, like a document for columns, document for a footing, document for beams, merge it together, okay? Rather than generating a report using this is called what? The report generator, this one. So this reports manager is going to give you a very big report, okay? So just like you, if you refer to the report that I sent in the group, you realize that a few elements have been reported about, okay? So that's how you can generate those reports. Like for example, if I can open here, now in that report there will be a first page, okay? That first page where you find you have captions of the 3D of your project, maybe which you have added using a snip, Windows snip, or a cover page. Then you start to talk about what you are designing. You have an introduction of your structure, talk about it. What is the structural system? What loads have you added? Okay. Then you put the design information as the next page, and also the template codes that you have adopted. Okay. Then you talk about a brief of the analysis steps that you have taken. What kind of analysis have you done? And then some captions of the layouts of the project. Okay. Then after that, now the reports that you have saved or merged, you're going to organize them in a way that you have a report about the pre-analysis checks. You have a report about the post-analysis checks. Okay. A report about rib beams, column design, footing design. Then combine them together to create a merged file. So it is this merged file that you have the design philosophy, the independent design reports for columns, beams, and foundations. Okay? Yes. But then when you use reports manager, it will give you, yes, a report which has also the table of contents, but it will have a lot of relevant information that is not needed. Okay? Yeah. So I'm going to share this file with you on the group. You can refer to it to organize your report. Now, after we have designed all our structural elements, you need to create details. So in Prota details, you can launch the details from here. So when you install Prota structure, it will have this other component, Prota details. So the best thing to do is to launch it within the project. So in the drawings and reports, we can click on Prota details. I'll click on plotter details. Then I'll click yes to save the changes. So now we are in a new environment of plotter structure. In this environment, works just like AutoCAD. You can like manipulate your details just like your AutoCAD. So within here, we can create automatic details using this option. So, but to create information which is a bit organized, you are not going to opt for this automatic generated drawings, okay? So it's better you start by creating a new drawing such that you output what you really need, okay? So we click on start by creating a new drawing. So in this environment, you're going to go to form plans. I'll click on form plans in this arrow. Click on that arrow. Then you have form plans, it's like a framing plan or like a plan of a drawing. So we have the foundation. Now, this foundation is very crucial when you want to export your details with the Axolotl information to AutoCAD. So I'll right click on foundation and I'll choose draw. Then we have options where you can include the form plan side dimensions. You can include column dimensions, but then this is not necessary. Don't include column dimensions. It will just congest the drawing. So we have inserting a quantity table and also inserting model information. So this is like a table for bills of quantities, like a rebar table, okay? Yes, for rough estimations. Then we can also insert to sheet. Plotter has template sheets that you can launch. Once you click on insert to sheet, you can click on this option to select the sheet size. You can choose from A0, A1, A2, A3. Maybe I need to insert them to A1, which is horizontal. I'll choose A1 plotter horizontal, and I'll click OK. Then in the options still we have, okay, we can show all this information, rebar information. Then in the options too, we ensure that everything is marked here. Then in option 3, this is important that we can mark topmost columns, where this will be like of help. It will be mostly at the terrace level. It will mark those columns that have to be terminated and mark those columns that have to be continued different. Okay, so you can mark topmost columns, and then you can select a hatch pattern for those columns. You can use a solid hatch. Also, if you have walls in your project, you can also hatch them using a solid hatch. Then, still under options, now our point of interest at the foundation is to show the axolotls. We can tick this box to display the column loads, and click on column loads and we mark actual load. So we are interested in the actual load, which are at the bottom, but they are unfactored loads. That is the GK and QK. So when designing foundations, we use information at substability limit state. So therefore, we expect our combinations to be 1.0 GK plus 1.0 QK. So we take these ones which are unfactored. I'll click OK, then choose to draw. After you've clicked on draw, you need to click, let's say, anywhere, like for example here, to draw the layout. Okay, so since you have chosen like to insert them on a sheet, which sheet you have selected, Plotter will put them in a template sheet, which is A1. So when you go into AutoCAD, it will save you time when you're trying to customize your title block. You can have a starting point for this title block. And then also we have the model information. It has not given us a rebar schedule. Yes. Yes. The drawing is not there, but mine is there. Yours is not there. Okay, you confirm with the next step. Let's go to plinth. Okay, let's recreate the drawing at plinth level. Now at plinth level, let's click on plinth beam level or ground floor level. Right click and choose draw. Now, there's no point of me placing the next drawing in a sheet. I already have a template sheet which already has one drawing. I can just copy and keep pasting that sheet to other drawings. So when I'm exporting this layout, I can turn off this insert to sheet. And this scale, when you are taking, like exporting your plans, you're going to maintain a scale of 1 to 50. So if I put a scale of 1 to 25, that means that the drawing is going to be bigger. The lower the scale, the bigger the drawing. If I put 100, then that means that the drawing will be compressed. Okay, now for this layout, let's turn off the column loads. We can display the form plan side dimensions. Form plan side dimensions, it means that these dimensions on the side, the layout. So we can keep them. If in case we don't need them, we can isolate them out while we are in AutoCAD. So we take all the options that we have marked as default. The moment you set the preferences for the first layout, these other options, they remain the same. So let's click on draw and I'll choose to draw it here outside the sheet. So it will give me a form plan side dimension and also a layout which includes the column marks. So you can start with this if you want to go into manual detailing. Okay, you now have where to start from rather than starting from zero. Plot has given you a starting point. Then let's go to FastFlow. Right click and choose draw. Insert quantity table, form plan side dimensions. Ensure everything is the way it should be with all these marked, like we have marked them before, with the hatching patterns still active. Then also the scale is 1 to 50. Then I'll choose draw. Now you observe where I'm clicking, okay? So where I click, it is okay. Assuming that I'm placing this plan here, I had to click at this point. Therefore, if I click here, I will expect my drawing to be placed as it is going down. Okay, this is where I click. It is the top left corner, or it will be like the origin of insertion of the drawing. So I'll put it below this layout. See, then I'll have a layout which includes also my slabs. Okay. Then that is FastFlow. You're not seeing your work. Okay, so you see, okay, in our project, we had it that from first floor up to, is it third floor, they were typical. So when you're exporting these drawings, especially the form plans, we can export first floor, we ignore second floor and third floor because they are the same. Then you can shift to fourth floor. So I'll go to fourth floor, right click on it and draw. Then I'll choose to have the form plan side dimensions. In whatever you're exporting, ensure that in your form plans that you're exporting don't include column dimensions, because it's going to dimension all those small columns and it will look so congested. Okay, so there's where we can in the column applications plans, that's where we can at least show the column sizing. Okay, so we're exporting fourth floor. You can right click on fourth floor and then choose draw, and I'll choose to draw. I'll put it below it. So this is fourth floor. Now, even if I don't take ring beam, the process is still repetitive. Okay, right click on the layout that you want and choose draw. Now, let's go to the form like application plans. I'll take the application plans for the ring beam level. So it is the ring beam level, sorry, the plinth beam level that you'll be most interested in regards to the application plans, because it's the one which will have the actual sizing of the columns. So let's right click on application plans and choose draw. Now in the application plans, we have, you can add link details or hide link details, show link details next to columns. You can choose one of these options, okay? So let's show link details, but most especially when like I'm designing, I hide these link details because the column will already have the link shown. Okay, that will be required. So this is like adding more information that is not necessary. So, but to see how it works, let's show the links next to columns. And then we can have column dimensions active, just maintain them the way they are. And then we can show column rebar details. Column rebar details, it's still, this is the repetition. Let's ignore this. So when you're practicing in your own free time, you can test how the drawing will come out if you activate this, okay? So now, what is most importantly here is the column dimensions, link details next to columns, and also the scale. We need to make this scale slightly lower such that we can have bigger columns indicated on the form plan. So I'll choose to draw, then I'll have the application plan. Since I've chosen the plinth beam level, I'll need to put it next to the plinth beam layout. Okay, so in this layout, actually even link details, it's just congesting the drawing. Okay. So when you are exporting your layouts, you can choose to hide the link details as well. So the importance of form plans, it's going to show you how many longitudinal bars you have in a column, how is the arrangement of links or ties, okay? So let's get to column elevation details. Now, it is possible for us to export column elevation details for the rest, like for all the layouts at once. But then, if I right click on, okay, you click on plinth beam level. Sorry. You choose column elevation details on first floor. Because remember, we designed columns for first floor. So go to first floor, then you can right click on one column which has green. You look into among the columns that you have, there should be a column which is green. That is the column that you designed. You remember? So it is better you export columns or members that have passed. So anything which is red, it is failing in proto structure. Okay, these are the ones which you corrected. So once right click on that column, you can choose to draw single story If I choose single story, I can place it here. So it will show me that the column is connecting from 5th beam level up to 1st floor. If I right click on it again, I can choose to draw through stories. So when you're exporting your columns, this is the right option to choose. Draw column through stories. You right click on that column and choose draw column elevation through stories. Then you choose from what story to what story. I can decide to draw that column from the foundation up to maybe any level. As I hold Control, I can select what levels I need to add. So let me have it complete up to the last level. So they have to be all selected. You select the levels that you want to connect and then click OK. You have your column like this. So there someone can tell that this structure, it has 1st floor, you got 2nd floor, 3rd floor, up to the top. This single story is useless. Now, there is possibility that we can right click on this heading, 1st floor, and we choose draw column elevations. Once we click on draw column elevations, in the options, you can decide how to sort them by size or by label. So let's just go with the default filtering options. So we are going to draw them. We are going to draw them all at once at this level. I'll click on draw. Then you choose where to draw. Like I want to draw them at this point. So it will generate all of them, but then the way how it will bring them, it will be single stories. Okay. So in case you want that kind of output, you can choose to draw them like that. So, but then how is it supposed to be done? You look at your layout, you are the one who has designed these columns, okay? So there will be those columns that will be unique. Look out for unique columns that you have designed and only export those columns to AutoCAD. Okay, so for example, I've chosen C2. There could be another column which is, let's say, if C2 is 300 by 300, there could be another column which is 400 by 400. Maybe if it is C16, I'll go look out for C16 and also export it. Also, those columns that have a change in level, those ones that are terminated at terrace level, those ones that are continuing, all those have different column IDs. Okay, you choose one among them and export it through stories. Okay, I'll right click on one column elevation, export through stories, and then add it here. I'll identify one column which ended at the terrace level, for example, this 17. I'll get, though it is in red, it can accept to add it, but it will be a failed column, okay? So once I add it here, it will show you that there will be a change in height of the column. So this you can have column C1, column C2, column C3. Why I'm having this one as with a different ID, yet they all have the same height, it's because the size of this column is different from the size of this column. It could be that the reinforcement pattern of this column is different from the reinforcement pattern of this column. Okay, so let's export the beam elevation details. Expand beam elevation details. I will export only one level, preferably the first floor. I'll right click on first floor. These ones, you can take them all at once. It's okay. So right click on first floor and choose draw beam elevations. Then you can click on draw. You notice the scale is 1:25. So choose draw. You can draw it below here. Okay. So this will be your beam elevation details. Now, you see the way how this beam looks like is being determined by the settings that you set. Like you see when you went to the settings center and adjusted the beam detail options. Those are the ones affecting like the cranking of beams. I don't know if I have some beam which is cranked. Okay, for example, here, the additional rebars, the bobs, how they are displaying. Okay, the sections are different support locations and also the span locations. Okay, so I would expect you to get this kind of output. So we also have rib beam elevation details. If in case you design the rib beams, you can export these rib beams. But then adding rib beam details may not be necessary. Actually, it's not necessary because your rib beams are going to be indicated in the slab layout. Okay. So in the slab layout, you indicate that maybe you need 4 bars per rib. For example, if here, once you draw the beam details and it is giving you, for example, if I place it here and it is giving you this kind of section, then in your slab details, you can put that you have 2 bars in a rib, top and bottom. Okay, but then we don't draw rib beam elevation details, no. Okay, so this you will not need it. Okay, so we go to pad footings. So in the pad footings, I don't know exactly which pad I designed fully. It is F16. Is it? Footings 6 and then and also F20 is 120. So now in the plotter details environment, I can get this footing, right click on it and draw. I add it here. I right click on this footing and draw, add it here. In case you want to get them all at once, you right click on the heading. On the heading, you draw pad footing details. Then you get this dialog box. You just choose to draw and choose to draw them, let's say there. To draw them all at once, but this is not necessary. Okay. So what will guide you on what exact footing details that you have to be exporting? It will be your foundation layout. Now, the foundation layout is going to be determined from this, the very first drawing that we exported. That will be at the foundation. So let's look at that detail after we have designed the staircase. Okay, remember in our model, we left a space for that staircase because the way how Prota deals with it, it is from within this environment. Within this environment, there are a variety of details that you can design. Retaining walls, box culverts. There are some, depending on when you check in the design library, you can design cantilever retaining walls, retrofit walls, everything here can be designed. So let's look at stairs. So in the stairs, under design library, you choose stairs. Now, how is the support system of your staircase? Is it this support system? Is it this support system? Is it this support system? Okay. So you choose the kind of staircase that is in your project. So our staircase is the first one. Okay. It has edge beams that are supporting the landings, the starting beam and the ending beam for the two landings. Now you put the preferences. I'll go to the story height. You put the story height. Our story height was 3 point what? What was our headroom? 3,200. Was it 3,200? Yes, 3.3. 3 meters. Don't know, you can confirm on the architecture, or actually even still here within Prota structure, you can confirm. Just go to building set out, story operations, and then be like you're editing the story. You have the headroom was 3 meters. Okay, so in our Prota details, our story height is going to be 3 meters here. You put 3,000 millimeters. Then we have the stair width. This preview here will guide you on what to input here. So the stair width is the stairwell, sorry, the flight width. Okay. So stair width B, I need to look at the space that I reserved for my staircase and plan accordingly. So let me switch to, let's say first floor. This is the region. I will measure from this point up to this point, 2.2. Okay. From this point up to this point is 2.2. Now, that means that my flight width is going to be 1.1. The recommended yes, that big is called the stairwell. That stairwell, because now the recommended flight width is 1.2 meters. And our total space that we have, including the stairwell, is 2.2. Maybe we can put it at 1 meter, then we have 100. Okay, can put it at 1 meter, 1 meter, decide then a stairwell of 200. Okay. But then remember there's still space where you need to put the They are called what? The railing. Okay. So basing on the 2.2 that I have, I'll need a stairwell of 100. Actually, at construction, it is very possible that you can even ignore that space in between. You just have stairs that are turned. You have this staircase coming, something like this. Okay. As this one comes, this one turns immediately without a space in between. You have seen this kind of construction before, just because of space. Okay. But then in the program, it cannot allow that kind of behavior. Okay. So it is a must, you need to have a stairwell. So in our plotter details, I'm going to say that let me have this being designed at 150. Is it? We said 1,000. Let me have this at 1,050. Then that leaves us with a BK. Where is BK? BK with a BK of 100. Okay. I don't know if I'm right. It's right, eh? Okay. So now let's set the landing width BSK. The landing width BSK what is the, if I try to measure, right click and measure from this point. Remember, this is already our landing. Okay, so we expect our by the time the staircase reaches here, you have your last step at this point. So this is going to be, we are going to take this one as our landing. Okay, then we are going to specify one landing, which is going to be equal to, which is going to be the same as the flight width. Okay, so one of our landings is going to be this, from this point up to this point, which is 100. So BSK, I'll put 100. And then the intermediate landing width, BSA, this one, we can have it as 1050. Okay. Then the plate thickness, that is the waist. The waist is going to be, let's keep it at 200. And then the plate thickness for the landing, we can maintain still 200. The stair hole, BK, this we have adjusted. And then the number of steps, yes. Then what we have here is the number of steps and the riser step. Now you notice that if I change the riser step, we have 150. Sorry, our total rise is 3 meters. Okay, so how many risers can we achieve with that? Both both flights, designs both flights. So you get 3 meters divided by 0.15. 20. So if I push this to 160, to give me decimal places, let's put this, the number of steps to be 20. Now, if I put 20 here, it is affecting the height. If I put, let's say 19 here, this will be affected. You get it? Now, there's a formula for calculating number of steps in staircase. It is 2 times riser plus the tread. Is it greater or equal to 575, or is it 600? 575. So if our riser is 150, we substitute this with an equal sign. Okay, so if you have a going of 280, if we have a going of 280, so that leaves us with 2R will be equivalent to 575 minus 280. That is what? 295. So if we get the 295 divided by the 150, I think it's what? So the other one is meters. The other one is meters. Is there something that I'm not getting right here? So I'm having 2R equal to 575 minus 280. Okay, 295. Okay, so it will give you 1 point what? 1 point has been 1.9 meters. You get 147.5. Now this is the formula, which is now the program is trying to relate with this formula in case we make an input here. It will not be perfect, but then what we know is that the number of threads, if like to get the number of threads that are required, or risers that are required, it will be that value minus when you minus 1, you get the number of threads, isn't it? So if we have them as 19, then that means that we need to add value to take them to 20. So we need to have 20 steps. So you have those inputs, and then you put the additional dead load for the floor finishes, then also for the live loads of the staircase, which is 4. And the support width, this is going to be the width of the beam, which is 200. And the support height, our beams were 400. Okay. The BK is 100. This is BK 100. No, it's 100. Looks like it's 100. Okay. So the support width and height, they are meaning the beam, width of the beam and depth of the beam. So I'll click on so our live load was 4 for staircase areas. Yes, balconies and staircases, it's the same live load. Support width is 200, the support height is 400. Then you click on detailed drawings. The staircase has not been designed yet. Okay, so let's click on redesign based on this input. Redesign. And then detailed drawings. Then choose where to place it, let's say there, and you have your staircase. That will be the staircase detail. In case you need a report, don't detail the drawings minus generating the report. Okay. Once you are finished, assuming that this is your input, it will still be the same. First click on design report to generate that report. And then after, you can click on detailed drawings. This report is a fake report. So just click on detailed drawings. So in case you want to make some iterations, once you have added your input, in the redesign, you will see it will give you rebar diameters of 16 and others are 8. Okay, so in case you want to revise the design with maybe 12 millimeter diameter, you can click on settings. And then you go to the stair part, adjust the rebar, minimum rebar to 12 or 10. And then also the maximum rebar, distribution rebar. Okay, you can have 12 and this distribution at 10. Then I'll click OK. And I'll get back and redesign. So I'll have 8 eliminated, but then the 16 has remained. That means that for that design to pass, you need T16. Then detailed drawings. Then place it here. Now, you have finished to generate your details. You need to take them to AutoCAD. Select File, save your project. And click Yes. what you're saving is this detailed job, so that if in case you want to open that job, you may not necessarily pass through ProtaStructure. You can instead access it right from this shortcut, even if you have not opened the ProtaStructure project. So you'll find it among your details that you have done. Now, exporting it to AutoCAD, you click on File, then you go to Export for External Software and choose Export to DWG. If you're not sure where to export it, you just click on Export. Just click on Export. ProtaStructure will create a folder within the project folder which has exported drawings. So you look for it from that project folder, and it will open instant. So once it has opened, I can right click on it and rename it as maybe export one, exported file. Why I'm renaming it is just in case maybe I have forgotten export some other detail, it will be very easy for me to open that detail I last exported, then create more details and then export. It will save it as drawing one, such that this other drawing that was exported previously is not overwritten. So that is our output. Yes. You're saying? Yeah. You opened it in AutoCAD. Okay, let's open our AutoCAD. I'll exit Prota details. I'll exit Prota structure. Then now what is left is to look at how are these drawings organized in this environment. So when I open AutoCAD, yes, it's now not necessary for you to be in Prota structure or Prota details. We are now entirely into AutoCAD. So you can save and close. Okay. So open that drawing in AutoCAD. So as per our assignment, as far as the assignment that I shared is concerned, we should work up to this step. Up to this step. Generate these drawings. And then what I'm going to take you through is it will take you some time on how to organize your drawings. Okay. So now in what I shared, there was a template drawing. When you check that folder that I shared with you, there are some sample structure drawing. So let me open that. Now, you'll be required to create one is going to be the foundation layout. So this foundation layout, you're going to organize it based at the plinth beam level. Okay. So in our details, in our details, you'll get, first of all, when you're in AutoCAD, most of these elements will not be like visible very well. You can select the beam line, right click on it and select similar and choose a color that is visible, maybe yellow. I'll go with yellow. See, these index colors are very good in a way that at the point of printing, they will be black. And that is what we need if in case you're exporting a drawing in monochrome. Okay. So now I'll get this plinth beam level and then copy it aside. I'll actually even draw a border around such that I have some drawings that are for reference and some drawings that have to be organized. Okay, so now I'll take this plinth beam level, this side, then you'll see these form plan side dimensions. They will not be clear. You'll be required to come up with a dimension style of your own. Or you can start with this very one and customize it to create a dimension that is clear. Okay, so I'll start with isolating this plinth beam level. Then select all these column marks and delete them. They are not necessary. These ones, you select similar and delete these column marks. Also, this beam information that is at the beam level, select similar and delete that detail. So what we need at this point is to label that all these are ground beams and of which they have the same property. Okay. Then at this level, you're going to add foundation strip. So when you check in the foundation layout, you need to show a detail of the plinth walls, whereby they will have a strip footing. So in your foundation layout, you'll be required to show the width of the foundation strip. So there, you just select one line and then offset it. Usually, the width of the foundation strip is 3 times the thickness of the walls. Okay, so you offset, if this is 200, you shall offset 200 either side of the walls. Okay, so I'll put 200 and then offset this side and offset that side, and I continue doing it for all the outlines of my walls or beams, these outlines. Okay, for me to create something which looks like this. So now you'll be required to at least add some form of hatching to show where the beams are going to pass and also the extent of the foundation strip. That is the only way you can differentiate them. You need to put some kind of hatching. Okay, so now for us to have it represented as also a foundation, like a foundation layout, you need to have column marks added there. Okay, so the column marks that we have deleted, they have been generic column marks. So we need to identify columns that are changing in sizes, that are changing in reinforcement, okay, and also that are changing in height. That will dictate the IDs of the columns that you're going to assign. For example, when you check this layout here, we have column C1, this column C2, this column C2, C2, okay? So it also helps you in coming up with types of columns that you're going to generate. Those are the column elevations which you're going to export from plotter details. Like for example, when you refer to our, if I end this object isolation, when we refer to our column application plan, this one, this layout will show you the sizing of the columns that you have here there are 12 T16s, here there are 12 T16s. When you check here, 12 T16s, okay, they were the same here because I didn't go into interactive design for all these columns. But then we need to assign different column IDs. So I can have, like for example, I'll get this and assign here that this is maybe C1, column C1, then copy it. This can be C1, C1, C1. So it also helps you in generating the bar bending schedule, okay? So here, if this is C1, C1, this is C2, 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 it will be easy for you to identify the members and the reinforcements in those varying members, okay? So next is to identify the footing IDs. So what is going to be helping you in adding those footings is going to be now this layout, which has axial loading, okay? Now, if I check in this layout, these are not visible enough. Let me select similar and try to increase the sizes of these labels and also change this to white. Okay, so now you look at columns that have the maximum axial loading, you're going to group them. This can be, you design this footing as footing F1. Then this footing F1 is going to be the same as footing, which is the next immediate axial load. This is 734, this is 706. You can group it that the footing of this column is going to be the same as the footing of this column, okay? To avoid designing two footings for two columns of which the axial loading is just nearby. So we can say that also this footing is going to be footing F1. Also, maybe the 700s are finished, then you can resort to 600s. Those columns which have axial loads of 600 and 500, you group them together. Like for example, I don't have 500 within here or 600, but what is next? Okay, 500 is here. I can group this one and I give it a different color, that this is going to be green. That is footing F2. So this footing F2 is going to be the same as this one, which is at 407. Is it going to be the same as this? It's going to be the same as this. Okay. So you when you are designing your footings in ProtaStructure, you do not design all the footings for the entire structure. You look out for the axial loads that you have grouped. Like for example, this is green, 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 green. You look among the greens, which column has the maximum axial load. That is the one which you identify and design that footing. Then you assign that footing for all those ones which are green. You get it. Likewise, you go on grouping all these other columns like that. So you have to get your slab layouts. These slab layouts that will be exported from ProtaStructure will not have clear reinforcement details. Okay, like for example, here, we designed this terrace level, but you can see how the reinforcements have been added there. It is hard to interpret. Okay, so it will require you to at least go into some manual detailing to represent those reinforcements very well, just like you can see in this layout. If I can get a slab layout which is having like, for example, here, this is a mixture of solid and ribbed. So I can have this one bar, major bar, and one distribution bar. Then I give it two descriptions. Likewise, for the next panel, also within the ribs, I pass through one bar, and I make sure that there is continuity added at points where I have the spans which are greater than 12 meters. So when you rely on Prota detailed drawings, it will not show you clearly this kind of arrangement where you need to lap these bars. Okay, so you need to go into plotter details where it's good plotter structure has given you the sizes of reinforcements that you need and the number. It's now upon you to arrange them and lap them where necessary. They should be lapped. Okay, so basically, then for the beam details, you can take them the way they are, but you need to ensure that how you fit them on paper, they are visible. Okay, so you can take, like, for example, it's upon you to arrange on how they are going to look like, but just ensure that the scale that you have given them, they are visible. So what you can take directly from plotter, yeah, they are going to be your beam details and also maybe the column elevation details. Then the footing details, you need to panel beat them, because in these footings, it's not necessary for us to have sections in either directions. It's just a section in one direction. Can cut off this, and then leave this, and then in your section details, you indicate that maybe at that level, you have a plinth beam. Let me get one footing detail. For example, here, you have a plan, and also a section above it. And that section should show the size of the plinth beam. How is the arrangement of the floor? Okay. Basically, our structural detailing will be for another day. Honestly, it's a journey of its own. Okay. So, but you can rely on that template that I shared with you and try to panel beat your details. So I'll end on that for our training. So your assignment, just produce this AutoCAD information. That will be all. Yes. I would like to thank you for your patience. Yes. Thank you. Thank you very much. I hope the training has been beneficial to you. In about 3 weeks, someone can be proficient. So you just concentrate, that's it. So I've extended the deadline of assignment to finish on 26th. Then on 27th, that will be Friday. After the CV classes. Yes, that is how it works. Yes, the certificate is given. So the person has done yes, our requesting has requested for group photo. One of you can give us a group photo.